Since the dawn of time, Earth has been bombarded by objects from space. Some of these celestial visitors were tiny meteors that burned up in the atmosphere, providing us with breathtaking meteor showers. But others were far more dangerous. Throughout history, asteroid impacts have shaped the course of life on Earth, from the extinction of the dinosaurs to massive craters that still scar our planet today. But what if we could change the course of history? What if, instead of waiting for the next asteroid to strike, we could stop it before it ever reached us? Join us as we explore one of the most critical challenges of our time, asteroid deflection. We'll uncover the threats that lurk in space, the cutting-edge technology designed to protect us, and the future of planetary defense. Before we discuss how we can stop an asteroid, we need to understand the real danger they pose. Earth has been hit by asteroids countless times in its 4.5 billion year history. One of the most famous impacts occurred 66 million years ago, when a 10-kilometer wide asteroid struck what is now the Yucatan Peninsula in Mexico. This impact released the energy of 10 billion atomic bombs, triggering wildfires, tsunamis, and a nuclear winter that wiped out 75% of all life on Earth, including the dinosaurs. The crater it left behind, the Chicxulub crater, is still visible today. More recently, in 1908, a powerful explosion flattened 2.0 square kilometers of Siberian forest in what is known as the Tunguska event. Though the asteroid never actually hit the ground, the force of the explosion was 1.0 times stronger than the Hiroshima bomb. And in 2013, the world witnessed a close call when an asteroid just 20 meters wide exploded over Chelyabinsk, Russia, injuring over 1,600 people and damaging thousands of buildings. If such a small asteroid could cause such widespread destruction, what would happen if something larger were on a collision course with Earth? To protect Earth, we first need to know what's coming. Astronomers worldwide are constantly searching for near-Earth objects, asteroids, and comets whose orbits bring them close to our planet. Some of the most powerful tools we have for detecting these space rocks include PAN-STARRS, Panoramic Survey Telescope and Rapid Response System. Located in Hawaii, it scans the sky for fast-moving objects. Catalina Sky Survey, based in Arizona, this system has discovered thousands of near-Earth asteroids. NEOWISE, Near-Earth Object Wide-Field Infrared Survey Explorer, a space telescope that helps detect asteroids too dark to be seen with visible light. NASA's Planetary Defense Coordination Office keeps a close eye on all known near-Earth asteroids. As of today, over 30 near-Earth objects, NEOs, have been discovered, but many remain undetected. One way scientists classify potential threats is using the Torino scale, which ranks asteroid impact risks from 0, no risk, to 10, certain impact and global catastrophe. Currently, no known asteroid ranks above level 1, meaning no immediate threat. But what if we discovered an asteroid heading directly toward us? How could we stop it? If an asteroid were on a collision course with Earth, scientists have several strategies to prevent impact. Kinetic impactor, hitting the asteroid head-on. The idea is simple. Slam a spacecraft into the asteroid at high speed to slightly change its trajectory. Even a small nudge can prevent a collision if done early enough. In 2022, NASA tested this concept with the DART Double Asteroid Redirection Test mission. The spacecraft deliberately crashed into Dimorphos, a small asteroid moon, successfully altering its orbit. This was humanity's first ever planetary defense test. Gravity tractor, a gentle tug. If we have more time, we can use a more delicate approach. By placing a spacecraft near an asteroid, its gravity can pull the asteroid off course over time. This method is slow but precise. Nuclear explosions, the last resort. If an asteroid is discovered too late for a kinetic impact or gravity tractor, a nuclear explosion might be the only option. Unlike in Hollywood movies, scientists don't want to blow the asteroid apart. that could create even more dangerous fragments. Instead, a nuclear detonation nearby could push it off course. Each of these methods has advantages and risks, and the best approach depends on the size, speed, and time before impact. But are we ready to use these techniques in an actual emergency? The success of the DART mission was just the beginning. More missions are being planned to advance asteroid defense technology. ESA's Hera mission. This European Space Agency mission will follow up on DART's impact to study the effects on Dimorphos. China's upcoming deflection test. China is planning its own asteroid deflection test in the coming decade, showing global interest in planetary defense. NASA's NEO Surveyor, a future space telescope designed to find and track potentially hazardous asteroids with greater accuracy than ever before. These missions are crucial because sooner or later, Earth will face another asteroid threat. The question is, will we be ready? For the first time in history, humanity has the technology to prevent an asteroid impact. But success depends on continued investment, international cooperation, and rapid advancements in space technology. From ancient civilizations that feared celestial omens to modern-day astronomers developing asteroid defense, one thing remains clear. Our survival depends on our ability to look up, predict, and act. The next time you see a shooting star, remember, it's not just a streak of light in the sky. It's a reminder that space is full of wonders and dangers. And with science, determination, and preparation, we can ensure that our planet remains safe for generations to come. Like, subscribe, stay curious,